Look at the sun right now, today in April 2026. Look at it carefully, because something is happening up there that the models did not fully predict. And the numbers coming in from NOAA and from space weather researchers around the world are telling a story that deserves far more attention than it is getting. Solar cycle 25 is collapsing faster than predicted. And the implications of what that means for our technology, our satellites, our planet, and the cycle that comes after this one are genuinely worth understanding deeply. So I want to take you through all of it. The real data, the real timeline, the real warning that is sitting inside a scientific paper published just a few months ago. Because when I dug into this properly, I had to go back and read it several times. Let me start with where we are right now. As of this week, the Earth-facing solar disk is extremely quiet. The sun, in recent days, has produced nothing stronger than low-level B-class flares. The weakest category, almost nothing. The solar flux reading, which measures the energy the sun is putting out, has dropped to around 96.7 solar flux units. That number, to give you context, was sitting above 220 SFU at the peak of this cycle just over a year ago. We have lost more than half of the sun's activity output in roughly 18 months. The monthly sunspot number for February 2026 came in at 78.2. That is the lowest monthly count since August 2022. Almost 3.5 years of progress reversed. And here is what is striking about that number. The models, the predictions that NOAA and NASA had running expected the February 2026 sunspot count to come in around 114.8. What actually arrived was 78.2. That is almost 1/3 lower than predicted. Researchers from the Space Research Institute of the Russian Academy of Sciences reported this data directly, and they said very carefully that the decline appears to be occurring faster than models anticipated. Further in this video, I'm going to explain why the polar field of the sun right now is the weakest it has been at this same stage in any of the last 5 solar cycles, and what that tells us about what comes next. But first, give this video a like and share it with someone who follows space weather or science. That helps this channel enormously, and this is the kind of information people need to know about. So let me build the full picture for you, because to understand what is happening right now, you need to understand the cycle itself. The sun operates on a roughly 11-year heartbeat. Scientists have been tracking this since 1755, 270 years of records. During the active phase, called solar maximum, sunspots multiply across the surface. Huge, dark, magnetically supercharged regions, each one a potential source of X-class solar flares, coronal mass ejections, geomagnetic storms that can knock out satellites, disrupt GPS, threaten power grids, even affect airline routes over the poles. Then the sun quiets down. Sunspots fade, the disk goes blank. That quiet period is called solar minimum. And between maximum and minimum is the declining phase where the cycle winds down. We are in that declining phase right now. Solar cycle 25 peaked. The smooth sunspot maximum hit 161 in October 2024. That number was nearly 40% higher than what NASA and NOAA originally predicted back in 2019 when they said the cycle would peak around 115. So the cycle surprised everyone on the way up. It roared far stronger than models expected. It gave us the most powerful geomagnetic storm in 20 years in May 2024. It delivered a stunning X9.0 solar flare on October 3rd, 2024. It gave millions of people around the world their first ever glimpse of the aurora. People in Greece, Italy, Mexico, the southern United States saw the northern lights for the first time in their lives, and it launched more X-class flares than any cycle in recent memory. By February 2026, solar cycle 25 had produced 101 confirmed X-class flares and over 1,690 moderate M-class flares. That is an extraordinary cycle, far stronger than anyone predicted at the start. But here is what cycles that peak high can do on the way down. They can drop fast, and that appears to be what is now happening. March 2026 came in at 85.9 sunspots. That was a slight recovery from February's low of 78.2, but it is still dramatically below where models expected the sun to be at this point. The Solar Terrestrial Activity Report, maintained by John Alvestad, stated explicitly, and I am paraphrasing carefully here, that solar activity appears to have exited the solar maximum phase as of February 2026, with a strong decrease in the number of sunspots observed. Exited the solar maximum phase. That is a significant statement. It means the sun crossed a threshold. And the question now is how fast and how deep the decline goes. Now let me tell you about something that I found when I went deeper into the research, something that caught me off guard. Because what is happening at the sun's poles right now is what will determine the strength of the entire next solar cycle. Here's how that works. The sun's polar magnetic field acts like a seed. At the end of each solar cycle, as sunspots die away, the magnetic energy from those sunspots drifts toward the poles. It builds up there over years, and that accumulated polar field is what powers the next cycle. The stronger the polar field at the end of cycle 25, the stronger solar cycle 26 will be. The weaker the polar field, the weaker cycle 26. This relationship is one of the most reliable predictors in solar science. Scientists measure it. They track it obsessively. And right now, researchers are watching something deeply concerning at the sun's north pole. In December 2025, a peer-reviewed paper was published by researchers including Ruihui Wang, using surface flux transport models and the most recent data from NASA's Solar Dynamics Observatory. The paper's title was direct. It was called, according to the Archive preprint, Prediction of the Solar Polar Fields in 2026, with the subtitle, An Unusually Weak Level Across the Last 5 Solar Cycles. Across the last 5 solar cycles. Read that again. 5 cycles. That takes us back to the 1980s. The paper predicted that the northern polar field of the sun would experience a pronounced decline until around March 2026, driven by sunspot regions with abnormal magnetic polarity that emerged between roughly June 2024 and March 2025. These regions deposited magnetic flux in the wrong orientation, and that flux drifted toward the North Pole and disrupted the field. The researchers described the effect as unavoidable, not possible, not likely, unavoidable, and the conclusion they reached was stark. By early 2026, the northern polar field would be exceptionally weak, the weakest it has been at a comparable phase compared to the last 5 cycles. And the southern polar field was not in great shape either. The Solar Terrestrial Activity Report confirmed this observation independently, noting that the northern polar field has weakened considerably over the last months. And it added something that stopped me when I read it. There is an increasing chance that solar cycle 26 will be very weak. An increasing chance. From the data being watched in real time, right now. So let me step back and explain why this matters beyond just scientific curiosity. Because I think sometimes when we talk about solar cycles and polar fields and sunspot numbers, it feels abstract. It feels like something that lives in data charts and observatory reports, but it is not abstract. When the sun is at maximum, our modern civilization faces genuine risks that most people have no awareness of. Strong geomagnetic storms can induce massive currents in power grid infrastructure. In 1989, a geomagnetic storm caused a complete province-wide blackout in Quebec, Canada, in just 92 seconds. 92 seconds from normal to total darkness for millions of people. That was not even a particularly extreme event by historical standards. Satellites in low Earth orbit experience increased atmospheric drag during solar maximum because the upper atmosphere expands when the sun is more active. This has real effects on GPS accuracy, on satellite lifetimes, on communication systems. The February 2022 Starlink incident, where 38 satellites were lost because a geomagnetic storm increased atmospheric drag, happened during a relatively mild period of cycle 25. 38 satellites gone in one night. And HF radio, the communications that long-haul aviation depends on over the poles, that shipping and military operations depend on, is disrupted during every solar flare event. When cycle 25 was at its peak, firing off X-class flares regularly, these disruptions were happening routinely. So solar maximum is genuinely dangerous for our technology, but the opposite direction carries its own risks. And this is where history becomes important. When the sun goes quiet for long periods, something different happens. Cosmic ray flux increases. When the sun's magnetic field is weak, the heliosphere, the enormous bubble of solar wind that surrounds our entire solar system, shrinks, and cosmic rays, high-energy particles from outside the solar system, penetrate more easily. These are particles that can affect cloud formation at lower altitudes. They affect the chemistry of the upper atmosphere. They increase radiation doses for aviation crews on polar routes. And they affect sensitive electronics on satellites. Now, I want to be careful here. I want to be precise. The science of how solar cycles affect Earth's climate is a genuinely complex and contested area. The mainstream scientific consensus is that greenhouse gas concentrations are the dominant driver of recent warming, and that the sun's total irradiance change across a solar cycle is only about 0.1%. That is a small number, but a small change in solar output applied consistently over decades is not negligible. And the question of whether cycle 26 might be significantly weaker than cycle 25 and what that means for the transition period between them is one that researchers are actively studying right now. The Solar Terrestrial Activity Report noted explicitly that there is a growing chance cycle 26 will be very weak. And several models, including work published in Nature's Scientific Reports using 276 years of sunspot data, project a significant decline from solar cycle 25's average of 150.6 in 2024 to a mean of around 85.3 in 2026, a decline of roughly 43% in 2 years. That is a very steep drop. Now, there is a historical parallel I want to explore with you, because when I found this, it genuinely made me think. A grand solar minimum is a period where sunspot activity essentially collapses for decades. Not just a few years, decades. The most famous one in recorded history is called the Maunder Minimum. It lasted from approximately 1645 to 1715, 70 years. During those 70 years, the sun was almost completely blank. Virtually no sunspots at all. Entire decades passed without significant solar activity, and this period overlapped with what historians call the Little Ice Age in Europe, characterized by exceptionally cold winters, rivers that normally never froze freezing solid, the Thames in London, the canals in Amsterdam, crop failures across multiple years, famines. The exact relationship between the Maunder Minimum and the Little Ice Age is still debated by climate scientists, but the correlation is real and documented. And here's the piece that a 2021 paper published in Nature's Scientific Reports found using high-precision carbon-14 analysis in ancient tree rings. The Maunder Minimum did not arrive suddenly. It built gradually. And critically, the paper found evidence that solar cycles were lengthening before the Maunder Minimum began. 3 solar cycles before the onset of the grand minimum, a cycle had lasted 16 years instead of the normal 11. And then the paper noted this. The sun has shown a tendency of cycle lengthening since solar cycle 23. Cycle 23 began in 1996, and the paper stated that the behavior of solar cycle 25 would be critically important to the later solar activity. Not interesting, not worth monitoring, critically important. So let me be very clear about what is and is not being said here. Nobody is declaring that a Maunder Minimum is beginning. NASA's official position, stated multiple times, is that there is no indication of an approaching Maunder-type minimum. And cycle 25 overshot predictions dramatically on the way up. It was far stronger than expected. So this is not a simple story of the sun quietly fading away. The sun surprised us in one direction, it could surprise us again. But what the data is telling us right now, what multiple independent measurement systems are confirming, is that the decline from the cycle 25 peak is happening faster than models predicted. That the polar field, which seeds the next cycle, is at its weakest level in 5 comparable cycles. That February 2026 sunspot counts came in almost 1/3 below forecast, and that the solar flux is running at a fraction of what it was at peak. These are not alarm bells. These are data points. But they are data points that serious solar researchers are watching with genuine attention right now. And there is one more dimension to this that I think is worth talking about. The connection to what happens to our technology in the transition. Because the transition from solar maximum to solar minimum is actually when certain types of space weather become more dangerous, not less. At maximum, yes, you have more flares, more coronal mass ejections. But at maximum, the sun's magnetic field is strong and coherent. During the descent toward minimum, the magnetic field becomes more fragmented and unpredictable. And historical analysis shows that some of the most geo-effectively dangerous solar storms occurred not at peak solar maximum, but during the declining phase. The famous Carrington event of 1859, the most powerful geomagnetic storm in recorded history, happened as cycle 10 was declining, not at its peak. If a Carrington-level event struck today, according to studies by NASA and NOAA, it could cause trillions of dollars in damage to global infrastructure, power grids, GPS, financial systems, communications, the things that modern civilization runs on. And the declining phase of cycle 25 is exactly when that risk remains elevated, while the sun's behavior becomes harder to predict. So, where does this leave us? Here is what we know for certain. Solar cycle 25 peaked in October 2024 with a smooth sunspot number of 161. The decline has begun. February 2026 came in at 78.2 sunspots, dramatically below the predicted 114.8. March recovered slightly to 85.9, but the trend is clearly downward. The solar flux is at a multi-year low. The northern polar field is at its weakest measured level across the last 5 solar cycles. And independent researchers are noting an increasing probability that solar cycle 26 will be significantly weaker than cycle 25. What we do not know, whether the February drop was a temporary fluctuation similar to one that happened briefly in May 2025, or the beginning of a steeper descent. Whether the polar field will recover meaningfully over the next 1 to 2 years before the cycle 25-26 minimum arrives. And whether solar cycle 26, when it begins around 2030, will carry enough energy to sustain the kind of activity we have seen in recent years. The Russian Space Research Institute scientists said specifically that March and April 2026 observations would be critical. If sunspot numbers fail to return to the predicted range of roughly 100 to 110, it would suggest that solar cycle 25 is weakening earlier and more rapidly than any model anticipated. March came in at 85.9, still below the 100 to 110 range. April data is being collected right now. As you watch this video, the tilt meters of the sun's magnetic field are being monitored. The space weather forecasters at NOAA's Space Weather Prediction Center are watching. And the solar physicists at observatories from Brussels to Moscow are watching. Because what happens to solar cycle 25 over the next 12 months will shape our understanding of what comes next. And what comes next affects every satellite above our heads, every power grid below our feet, every long-haul flight crossing the poles, every GPS signal guiding your phone, every communication system that modern life depends on. The sun does not need to be angry to matter. Sometimes what the sun does when it goes quiet is just as important as what it does when it roars. Right now, it is going quiet, faster than predicted. And the polar fields that seed the future are weaker than they have been at this same moment in 5 consecutive solar cycles. That is what the data says. That is what the instruments are reading. That is what I am watching for you. I will be covering every update on this as the April and May sunspot numbers come in. Everything is linked in the end screen. And if you want to support this channel and keep this kind of deep analysis coming, you know where to find me. Stay safe, guys. Be aware. Bye-bye.